The weather radar showed clear skies. Every smartphone in the canyon displayed the same message: perfect camping conditions for the next 24 hours. But the 73-year-old Navajo grandmother wasn't looking at screens. She was reading the desert itself, and what she saw made her insist that all 47 people leave the canyon immediately. 4 hours later, a 20-foot wall of water roared through that exact spot. The campsite vanished under churning mud and debris. But everyone was safe. They had listened to her warning. They had trusted ancient knowledge over modern technology. The National Weather Service didn't issue their flash flood warning until 30 minutes before the water hit. By then, it would have been too late to escape. This grandmother wasn't guessing. She wasn't getting lucky. She was using weather-reading skills passed down through countless generations of dying people. Skills that work better than radar in the desert. Skills that can save your life. Here's something that will shock you. Flash floods kill more people in the American Southwest than lightning, tornadoes, and hurricanes combined. Every year, hikers, campers, and even experienced outdoors people die in desert canyons. The water comes so fast that modern warning systems can't help. Cell phones don't work in deep canyons. Weather apps show blue skies while deadly storms gather 50 miles away. Radar can't see what's coming until it's already too late. But Navajo ancestors figured this out 600 years ago. They had to. Their survival depended on it. Welcome to the Navajo Nation. This land stretches across 27,000 square miles of high desert. It covers parts of Arizona, New Mexico, and Utah. This is the Four Corners region where ancient red rocks meet endless sky. It's one of the most beautiful places on Earth. It's also one of the most dangerous. The danger hides in plain sight. Dry washes cut through the landscape like scars. These arroyos look harmless most of the year, just sandy ditches with maybe a trickle of water. But when storms hit, everything changes in minutes. A bone-dry wash can transform into a raging river 20 feet deep. The water moves so fast it carries boulders the size of cars. It strips away everything in its path. The DNA people learned to read the signs. They had to predict these floods hours before they arrived. They developed a weather reading system so smart that modern scientists are still studying it. This system uses 5 different layers of information: cloud formations, animal behavior, plant responses, air pressure changes, geological indicators. Each layer confirms the others. Together they create a warning system that works when technology fails. And here's the incredible part. This traditional knowledge provides 2 to 6 hours of advance warning. Modern radar, 15 to 30 minutes at best. Often less in canyon country where the radar can't see between rock walls. Today, elite search and rescue teams train in these methods. The National Weather Service consults with Navajo weather experts. Wilderness survival schools across the country teach these ancestral techniques. Instructors like Tom Brown III and Cody Lundin have spent decades learning from native teachers. They know these skills work better than apps and satellites when you're deep in the desert. Grand Canyon Park rangers now use traditional indicators to make evacuation decisions. They've learned that old wisdom beats new technology in places where modern tools fail. Let me take you back in time. Stand with me in Canyon de Chelly at dawn in the 1840s. The sun hasn't risen yet, but the sky glows purple and orange. Towering sandstone cliffs surround us, their faces carved by ancient water. At the base of these cliffs, smoke rises from a traditional Navajo home called a hogan. An elderly woman steps outside. Her weathered face turns toward the sky. She's not just looking, she's reading. Her granddaughter, maybe 10 years old, stands beside her. The girl is learning skills that will keep her family alive for decades to come. The old woman points at clouds forming over the distant mesas. She sniffs the air. She watches how smoke from their fire behaves. She notices which direction the birds are flying. She touches the sandstone cliff and feels something the girl doesn't yet understand. She's sensing moisture that has travelled through rock from storms far away. Listen, she tells her granddaughter in their language, Dine Bizard. The desert is speaking. This scene played out countless times across Navajo lands. Knowledge passed from grandmother to grandchild, from father to son, from aunt to nephew. Generation after generation learning to survive in a landscape that doesn't forgive mistakes. By the end of this video, you'll understand what that grandmother knew. You'll learn to recognize 5 critical warning signs that appear hours before modern technology detects danger. You'll discover how to read cumulus clouds like a book. You'll learn what animal behaviours mean when you see them. You'll understand how canyon winds tell you what's coming. You'll know which plant responses signal approaching storms. These aren't just interesting facts. This is survival knowledge. Climate change is making flash floods more frequent and more deadly. Heat waves create more violent monsoon storms. Dry ground can't absorb sudden rainfall. The conditions that made this knowledge essential 600 years ago are getting more extreme right now. Whether you hike in the southwest, live in desert regions, or just want to understand how our ancestors outsmarted nature's deadliest weather, this knowledge matters. It could save your life. It will definitely change how you see the world around you. The Diné people call themselves Diné, which means the people in their language. The name Navajo came from Spanish colonizers. Today both names are used, but Diné is the proper term that honours their own language. Throughout this video you'll hear both names because that's how Navajo people themselves often speak in English. Some traditional knowledge is sacred. Some teachings belong only to certain families or clans. What you'll learn here comes from published sources and shared knowledge that Navajo teachers have chosen to make public. We're not revealing secrets. We're sharing wisdom that the Diné people have generously taught to others who approach with respect. But these remarkable survival skills didn't develop overnight. To understand why Navajo weather reading became the most sophisticated flood prediction system in North America, we need to journey back to the ancestral migrations that brought the Diné people to one of Earth's most beautiful and most deadly desert landscapes. The Navajo weren't always desert dwellers. Their ancestors came from one of the coldest places in North America. Imagine forests so thick that sunlight barely reaches the ground. Lakes frozen solid for 8 months a year. Temperatures dropping to 60 below zero. This was home for the Athabascan people who would become the Diné. Around 1400 CE, something changed. Groups of Athabascan speakers began moving south. This wasn't a quick trip. Families travelled for generations. They walked from subarctic Canada down through the Rocky Mountains. They crossed high plains and mountain passes. The journey took over 100 years. Some groups became the Apache peoples. Others kept moving until they reached the Four Corners region. These became the Navajo. Linguists can still hear the connection today. Navajo and Apache languages come from the same Athabascan family. Words that described snow and ice in Canada slowly changed to describe sand and sun, but the structure stayed the same. It's like finding your cousin's accent in your own voice even though you grew up in different places. Think about what this migration meant. These people went from hunting caribou in snowy forests to tracking deer in Red Rock canyons, from reading ice conditions to reading sandstone, from predicting blizzards to predicting flash floods. They had to learn an entirely new environment or die trying. And they didn't just survive, they mastered it. The land they settled at that was beautiful and brutal. The Four Corners High Desert sits at 5,000 to 7,000 feet elevation. Summer temperatures climb above 110 degrees. Winter nights drop below 10 degrees. That's a range of over 100 degrees. Your body has to handle both extremes, but temperature wasn't the biggest challenge. Water was. This desert gets most of its rain during monsoon season. That runs from July through September and through September. During these 3 months, 80% of flash floods happen. The rest of the year stays mostly dry. So the Diné people had to master reading these violent summer storms or face deadly consequences. Here's what makes this landscape so dangerous. In this terrain, a storm 50 miles away can kill you in minutes with zero rain falling where you stand. You might be hiking under blue skies while thunderstorms pound distant mountains. All that water funnels into arroyos. These dry washes act like gutters, collecting rain from areas covering 50 or more square miles. The water concentrates and accelerates. By the time it reaches you, it's a wall of destruction moving faster than you can run. The geology makes it worse. This is the Colorado Plateau. Ancient seas deposited layers of sandstone, limestone and shale over millions of years. Then the whole plateau lifted up thousands of feet. Rain and wind carved this rock into the shapes we see today. Slot canyons, hoodoos, mesas, arroyos. Every formation channels water in specific ways. Sandstone soaks up water slowly. The rock can actually feel damp hours before visible water appears. Ancient Navajo weather readers learned to touch cliff faces and sense approaching moisture travelling through stone. This geological characteristic became one of their warning signs. Badland topography concentrates runoff even more. When hard summer rains hit dried clay soil, the water doesn't soak in. It just runs off. Every little depression becomes a stream. Every stream feeds into washes. Every wash feeds into larger arroyos. The whole system acts like a funnel aimed at the low points where people naturally camp and travel. The Diné people had to figure all this out through observation and experience. Every generation added to the knowledge. Families shared what they learned. Clans developed specialties based on where they lived and what they noticed. Some Navajo people became known as especially skilled weather readers. In traditional society, certain individuals called Hatawi served as medicine people and ceremonial leaders. Many of these respected community members held deep knowledge about weather patterns. They understood the connections between sky, land, animals, and plants. They could read signs that others missed. But weather reading wasn't just for specialists. Every Navajo child learned the basics before age 10. This wasn't optional education. Failing to learn these skills could mean your family's death, so grandmothers taught granddaughters, fathers taught sons. Aunts and uncles made sure every child could recognize danger signs. The knowledge was preserved through oral tradition. Stories embedded survival information. The Diné Bahane, the Navajo creation narrative, contains weather wisdom woven into sacred stories. Seasonal ceremonies aligned with monsoon cycles. When certain rituals happened, everyone knew what weather patterns to watch for. The ceremonial calendar itself taught weather prediction. Different clans specialized in different knowledge. Some families lived near particular canyons for generations. They learned every detail of how water behaved in their specific landscape. Other clans traveled more widely. They understood regional weather patterns across hundreds of miles. This clan-based system meant knowledge accumulated and spread throughout Navajo society. Archaeological evidence proves how well this system worked. Researchers studying ancestral pueblo and cliff dwellings noticed something remarkable. These ancient structures were always positioned above historical high water marks. The people who built them understood exactly how high floods could reach. They placed their homes just beyond danger. When Navajo people moved into the region, they learned from these ancient lessons, but they added their own observations too. Studies of traditional Navajo hogan sites show incredible precision. Families chose building locations that avoided flood zones while staying close to water sources. They needed to be near streams for daily use, but above the floodline for safety. Here's something that stunned archaeologists. When they studied Navajo settlements that survived the historic 1911 flood, they found not one had been damaged. That flood was massive. It destroyed many newer structures built by people who didn't know the land. But traditional Navajo homes stood untouched. 600 years of accumulated knowledge had taught the Diné exactly where to build. Petroglyphs carved into canyon walls document major flood events. Some show water levels reaching heights that seem impossible until you understand the geology. These rock carvings served as permanent records. They warned future generations. They said, "Water reached this high." Remember, the environmental pressure never let up. Every summer brought new storms. Every monsoon season tested survival skills. Families who couldn't read the signs didn't survive to pass on their genes or their knowledge. This harsh reality drove innovation. It created a culture where weather reading became as natural as breathing. Mothers tested their children. What do those clouds mean? Which way is that bird flying and why? Feel this rock. What does it tell you? Kids who paid attention lived. Kids who didn't faced consequences. This might sound harsh to modern ears, but it created one of the most sophisticated traditional weather prediction systems on Earth. The Diné people weren't just surviving. They were thriving in an environment that kills unprepared people every single year. Modern Navajo Nation emergency management combines this ancestral wisdom with contemporary technology. Weather services consult with traditional knowledge holders. Warning systems incorporate both radar data and reports from elders who read the desert itself. This blending of old and new creates better outcomes than either system alone. Linguistic anthropologists have studied the Diné language and found something fascinating. Navajo has incredibly rich vocabulary for describing weather, clouds, water, and storm behaviours. The language evolved to capture subtle distinctions that English can't easily express. One Navajo word might describe a specific type of cloud formation that requires a whole sentence in English. This linguistic richness reflects centuries of careful observation and knowledge sharing. Climate change is making this traditional knowledge more important than ever. Modern weather patterns are becoming more extreme and less predictable. Heat waves create more violent monsoons. Droughts make soil harder, increasing runoff when rain finally comes. The historical patterns are shifting. But the underlying principles of observation and awareness still work. Traditional knowledge adapts because it's based on reading what's actually happening, not just following historical averages. Archaeological site preservation efforts now document traditional placement wisdom. Researchers work with Navajo consultants to understand why ancestors chose specific locations. This collaboration helps preserve both physical sites and the knowledge systems that created them. It's not just about protecting old buildings, it's about keeping alive the understanding of how humans can live safely in challenging environments. This centuries-long relationship with one of nature's deadliest weather events produced something remarkable. A multi-layered early warning system that engaged all 5 senses, plus deep environmental observation. Let me show you exactly how traditional Navajo weather readers predicted flash floods hours before they arrived. The first warning sign appears in the morning sky. Most people see clouds. Navajo weather readers see a ticking clock. They know exactly how much time they have before danger arrives. Let me show you how this works. Traditional Diné weather. Prediction uses 5 layers of information. Each layer works independently, but together they create a complete picture. Think of it like a puzzle. Each piece confirms the others. When all 5 layers agree, you know exactly what's coming and when it will hit. Layer 1. Reading the clouds. Stand outside at dawn during monsoon season. Look at the sky. You'll probably see puffy white clouds forming over distant mountains. These are cumulus clouds. They look harmless. But a trained weather reader sees much more. Check the bottom of these clouds. Is it flat and level? That's normal. The cloud is just floating. But watch what happens as morning turns to afternoon. Some clouds start growing taller. Their tops push higher into the sky. These are building clouds. They're pulling moisture up from below. The taller they grow, the more energy they contain. By noon, some clouds tower thousands of feet high. Their tops might reach 40,000 feet or more. At this height, the top of the cloud hits freezing air. It spreads out flat like an anvil on a blacksmith's table. Navajo weather readers have a specific word for this anvil shape. It means dangerous cloud in their language. Watch the base of these tall clouds. Is it getting darker? Dark grey or black means heavy rain is already falling somewhere. That rain is hitting ground 50 or more miles away, but in a few hours all that water will funnel into arroyos. It's heading your way even though the sky above you looks clear. Here's how to calculate your time. Look at how tall the cloud is. Look at how far away it stands. A fully developed thunderstorm with an anvil top takes about 2 hours to reach you if it's 20 miles away. Storms generally move at 10 to 15 miles per hour in this region. So you can estimate, tall anvil cloud, 20 miles distant. You have roughly 2 hours before the rain hits your location. Add another hour for water to travel through the arroyo system. That gives you 3 hours total to reach safety. Traditional Navajo weather readers taught their children to track multiple clouds. Storms don't travel alone during monsoon season. Watch for lines of storms. Watch for storms coming from different directions. When 2 storm systems meet, the flooding gets much worse. The Diné have specific terms for storm personalities. Some storms move fast and hit hard. Others move slowly but drop more rain. Learning to recognize these personalities takes years, but the basics will keep you alive. Ravens drop in altitude by several hundred feet 4 hours before floods arrive. They're reading barometric pressure changes that you can't feel yet. This brings us to Layer 2. Layer 2, watching the animals. Animals sense atmospheric pressure better than humans. They feel the changes in their bodies. When a big storm approaches, air pressure drops. Animals respond to this drop hours before storms arrive. Watch the birds. Ravens and hawks normally soar high using thermal currents, but 3 to 4 hours before a major storm they fly much lower. Sometimes they land completely. They know high altitude will soon become dangerous. The pressure changes tell them to come down. Look at the insects. Ants are incredibly sensitive to humidity and pressure changes. 6 hours before storms, worker ants start blocking their colony entrances. They pile up sand and debris. They are preparing for flooding. If you see ants frantically working on their mounds in unusual ways, pay attention. They know something you don't. Bees return to their hives early when storms approach. Normally bees work until sunset, but before major weather, they head home 2 or 3 hours early. The whole hive knows. Watch for bees streaming back when the sun is still high. Grasshoppers change their behaviour too. These insects usually hop freely through grass and bushes, but before storms, they hunker down near the ground. They become still. They're trying to avoid being caught in high winds that haven't arrived yet. If you have livestock, they'll tell you what's coming. Horses and sheep seek high ground before floods. They cluster together. They seem restless and nervous. Navajo herders learn to trust their animals. When the flock moves to higher ground without being driven there, follow them. They're reading signs you might miss. Even reptiles react. Desert lizards normally sun themselves on rocks during hot afternoons, but 2 to 3 hours before storms, they disappear into burrows. They're seeking shelter from coming rain and temperature drops. Here's something really interesting. Toads that normally only come out at night will emerge during the day before big rains. These amphibians have been dormant underground, waiting for moisture. When humidity spikes before a storm, they sense it through the soil. They come up early knowing water is finally coming. Predators change their patterns too. Coyote howling shifts in tone and frequency when pressure drops. Experienced listeners can hear the difference. Bobcats that normally avoid daytime will appear in open areas. The pressure changes affect their hunting behaviour and decision-making. Meteorologists confirmed cottonwood leaves rotate 45 minutes before their instruments detect wind shifts. Plants don't lie. Layer 3. Reading the plants. Plants can't run from danger, so they evolved to sense and respond to atmospheric changes. Navajo weather readers learned to read these plant signals like a telegraph system. Cottonwood trees are the most reliable. These trees grow near water sources throughout the southwest. Their leaves hang on flexible stems. Watch how the leaves orient themselves. On calm days you mostly see the dark green top surface, but when wind patterns change before storms, the leaves twist. Suddenly you see flashes of silver. That's the light-coloured underside reflecting sun. This leaf rotation happens because wind starts coming from different directions. The storm is still distant, but atmospheric changes reach you first. Cottonwood leaves detect these changes 45 minutes before weather instruments do. Traditional weather readers called this the cottonwood telegraph. When the whole tree flashes silver, a storm is definitely coming. Smell the air around sagebrush and creosote bushes. These desert plants release stronger scents when humidity increases. The oils in their leaves volatilize more in damp air. If you walk through sage country and suddenly smell it much more strongly, humidity is rising, storm moisture is arriving. Desert wildflowers react to pressure changes. Flowers that should be open in sunlight will close tight when atmospheric pressure drops. The plants sense the change even though the sky looks clear. If you see closed flowers at midday, pressure is dropping. Storms are building somewhere nearby. Watch the grass. Desert grasses bend in ways that show wind direction. But before storms, wind becomes inconsistent. Grass bends multiple directions within seconds. This chaos means atmospheric instability. The normal wind patterns are breaking down. Storm systems are interfering with regular airflow. Tree canopies make different sounds when wind changes. A steady breeze creates consistent rustling. But pre-storm winds gust and shift. Listen for changes in the sound pattern. Experienced weather readers could identify approaching storms just from how trees sounded in changing wind. If you see these 3 signs together, you have approximately 90 minutes to reach high ground. Now let's add another layer. Layer 4. Feeling the atmosphere. Your body can sense atmospheric changes if you pay attention. Navajo weather readers trained themselves to notice subtle shifts that most people ignore. Look at distant landmarks, mountains or mesas that you can normally see clearly. On ordinary days, dust in the air makes them slightly hazy. But when moisture increases before storms, visibility actually improves. Those distant landmarks look sharper and clearer. This seems backwards, but it happens because water vapour is denser than dust. The moisture pulls dust particles down. You can suddenly see 30 or 40 miles with unusual clarity. This clarity means humidity is spiking. Storms are approaching. Feel the temperature. Desert afternoons are hot, but 2 to 3 hours before big storms, you might notice something strange. Cool air sinks into valleys even though the sun is still high. This is called temperature inversion. The normal pattern reverses. Cold air that should be rising gets pushed down by atmospheric changes. If you feel unexpected coolness on a hot afternoon, suspect approaching storms. Wind patterns tell you everything. Normal desert mornings are calm. Afternoon winds pick up from predictable directions, but before storms this pattern breaks. Morning calm suddenly shifts to gusty, inconsistent wind. The gusts come from strange directions. They stop and start unpredictably. This chaos means storm systems are affecting your area, even though they're still miles away. Pay attention to your skin. Does it feel damp? Is your shirt sticking to your back more than usual? Humidity is invisible, but your body senses it. In the normally dry desert air, sudden humidity is a major warning sign. Leather items swell when humidity increases. Boots feel tighter. Belts expand, ropes become less flexible. If you carry leather gear, it acts as a natural humidity detector. Sound behaves differently in changing atmospheric conditions. Echoes in canyons change timing when temperature and humidity shift. Distant thunder becomes audible from farther away than normal. Your voice carries differently. Experienced canyon travelers notice these acoustic changes. They're reading air density shifts that precede storms. Search and rescue teams now check for these plant signals because they're more reliable than weather apps in canyons. But there's one more layer that brings everything together. Layer 5. Reading the ground. The Earth itself provides warnings. Geological indicators appear hours before visible water arrives. Walk into a dry arroyo, dig your hand into the sand a few inches down. Is it damp? Subsurface moisture appears 3 to 4 hours before surface water. This moisture comes from two sources. First, distant rainfall soaks into upland areas. The water percolates down through soil and rock. It travels underground faster than surface water. It emerges in arroyos as dampness long before floods arrive. Second, humidity before storms condenses in cooler underground sand. Either way, damp sand in a dry wash means water is coming. Touch the canyon walls. Sandstone has a quality that makes it perfect for prediction. This rock is porous. Water can move through it slowly. When storms dump rain on distant plateaus, that water starts soaking into rock layers. Hours later, moisture reaches canyon walls miles away. The rock face sweats. It looks and feels damp. If you touch dry-looking sandstone and find it moist, water is percolating through from upland storms. Major runoff is coming. Listen to canyon acoustics. Canyons amplify sounds in specific ways. Wind moving through canyon systems creates echo effects. As atmospheric conditions change before storms, these acoustics shift. Echoes time differently. Wind tunnel effects intensify. Experienced canyon travelers recognize these changes. The canyon is telling them something's different about the air. Feel the ground temperature. Put your palm on bare dirt or rock. Normal afternoon ground is hot, but hours before floods, ground temperature starts dropping. This happens because approaching moisture affects thermal conditions. The ground is responding to changes you can't see yet. Watch for spring behavior changes. Desert springs and seeps come from underground aquifers. When major rainfall hits upland areas, it affects aquifer pressure. Springs flow faster. Water clarity changes. Temperature drops as fresh cold water pushes through. These changes appear 1 to 2 hours before surface flooding. Traditional Navajo camps were often near springs. People checked spring behavior daily. Changes meant flooding was imminent. Putting all 5 layers together creates certainty. Maybe you see 1 or 2 signs and you're not sure. But when cloud formations show anvils, birds fly low, cottonwoods flash silver, humidity spikes and arroyo sand feels damp, you know absolutely that flooding is coming. Each layer confirms the others. The system works because it doesn't rely on single indicators. It builds a complete picture. Time to threat calculation comes from combining the layers. Distant anvil clouds give you 2 hours. Animal behavior suggests 3 to 4 hours. Plant responses indicate 1 to 2 hours. Atmospheric changes mean 1 hour or less. Geological signs show 30 minutes to 2 hours. When you see all 5 layers activated, you choose the shortest time frame and act immediately. Modern weather radar can detect rain, but radar can't see between canyon walls. Cell service fails in remote areas. Weather apps show what's happening where satellites and radar stations can see. But in canyon country with complex terrain, traditional indicators work better. They're reading local conditions that technology misses. They're giving you information that matters exactly where you stand. These 5 layers create a remarkably reliable system. But Navajo ancestors didn't stop there. They developed specialized variations for different seasons, canyon types, and storm patterns. Let me show you the advanced techniques that separate basic practitioners from true masters of desert flood prediction. Master weather readers could distinguish between 12 different storm personalities. Each one required different response strategies. This wasn't guessing. This was a lifetime of observation condensed into split-second recognition. Let me show you how deep this knowledge goes. Understanding the seasons. See, in summer, monsoons behave completely differently than winter storms. If you learn only summer patterns, you'll misread winter danger. Traditional Navajo weather readers mastered both. Summer monsoons run from July through September. These storms follow predictable daily patterns. Morning starts clear and calm. By 10 or 11 o'clock, clouds begin forming over mountains. The desert floor heats up fast. Hot air rises. This pulls moist air up from the Gulf of California and Gulf of Mexico. By 2 or 3 in the afternoon, thunderstorms explode over high country. Rain falls hard and fast. Within an hour or two, the storm moves or dissipates. Then the cycle repeats the next day. This predictability helps you plan. Check the sky at noon. See building towers? You know afternoon storms are coming. You have 2 to 4 hours to finish your travel through dangerous canyons. Get to high ground by mid-afternoon. Wait out the storm. Return to low ground by evening when danger passes. But winter changes everything. December through March brings different storm systems. These aren't afternoon heat-driven events. These are frontal passages. Cold air masses from the north collide with warmer air. These storms can last for days. They drop rain or snow steadily instead of in quick bursts. The warning time is longer because you can see the front approaching for 12 to 24 hours, but the danger lasts much longer too. You can't just wait an hour and return. The whole system might sit over the region for 3 days. Winter storms often start as snow at high elevations. That snow melts as temperatures rise or as the storm track shifts. Suddenly you get rain on top of snowpack. This creates massive runoff. Every canyon fills with water. The flooding can continue for days after the rain stops because snow keeps melting. Spring brings the most complex conditions. March through May combines snowmelt with new storms. Base flows in streams are already elevated from melting mountain snow. Then spring storms add precipitation on top. A moderate storm that would cause minor flooding in summer can create major floods in spring because the baseline is already high. Traditional weather readers tracked snowpack levels all winter. They knew whether spring would bring normal or dangerous conditions. Here's something that modern people often miss. After long droughts, the ground hardens. Desert clay soil bakes like pottery. When the first big storm finally arrives, water can't soak in. It just runs off. First storm flooding after drought can be worse than later storms, even if the rainfall is similar. Navajo weather readers watched for drought to deluge transitions. They warned communities that the first monsoon after dry months would be especially dangerous. Traditional knowledge also tracked multi-year cycles. The Diné people recognized patterns that modern science calls El Niño and La Niña. They didn't use those Spanish names, but they observed that some years brought unusually wet conditions while others brought drought. These patterns followed cycles lasting several years. Elders remembered what happened in previous cycles. They shared warnings when conditions matched dangerous past years. In 1997, a Navajo family survived a Slot Canyon flash flood by recognizing one advanced signal that contradicted the weather forecast. The forecast said low rain chances. But the family noticed something experienced weather readers understand. The atmospheric setup matched a dangerous pattern, even though no storms were visible yet. Reading different canyon types. Not all canyons flood the same way. Master-level weather reading requires understanding specific canyon characteristics. Slot canyons present special hazards. These narrow passages cut deep into rock. Walls rise hundreds of feet. The sky becomes a thin ribbon far above. You can't see clouds building. You can't watch storm approaches. Visual skywatching doesn't work here. Instead, you must rely on acoustic signals and touch-based rock moisture detection. In slot canyons, sound becomes your primary tool. Listen for echo changes. Feel for wind pressure shifts. Touch the walls, constantly checking for moisture. If rock faces turn damp, exit immediately. You might have only 15 to 20 minutes once moisture appears on slot canyon walls. There's often no high ground inside slots. Your only option is complete evacuation. Wide wash systems work differently. Here you can see the sky. Visual cloud tracking becomes your priority, but wide washes collect water from multiple tributaries. You must monitor not just the canyon you're in, but all the side canyons feeding it. A wash can flood from tributary input even if the main canyon looks dry. Traditional weather readers memorized watershed shapes. They knew which tributaries contributed most water. They positioned themselves where they could watch multiple valleys at once. Box canyons are death traps. These canyons have only one entrance and exit. High walls surround you on 3 sides. If water comes in the entrance, you're trapped. Navajo people identified these no-escape zones and avoided them during storm season. Before entering any canyon, traditional practice required assessing whether high ground existed inside. Could you climb out if you needed to? If not, don't enter when any storm threat exists. Side canyon refuges saved countless lives. Experienced travelers identified elevated benches and alcoves before starting canyon journeys. They mentally marked these safe zones. If flooding started, they knew exactly where to climb. Some families placed rock cairns marking proven refuge spots. These traditional marking systems passed information across generations. Mesa base areas create unique wind patterns. When storms approach, wind gets funneled and concentrated around mesa edges. Air currents swirl in predictable ways. Weather readers positioned near mesas could feel these thermal currents shifting. The changes told them exactly where storms were relative to their position. Researchers discovered traditional multi-day predictions were 78% accurate compared to 62% for 3-day weather forecasts. How did they do this? Master-level prediction rule. Skills. Expert weather readers recognized storm personalities. Some storms moved slowly. These dropped massive rain in concentrated areas. Flooding would be extreme but localized. Other storms moved fast. These created less total rainfall but affected larger areas. Fast-moving storms meant you needed to evacuate quickly, but the danger would pass sooner. Multi-cell storms versus supercell storms behave completely differently. Multi-cell storms are clusters of thunderstorms working together. One cell builds while another dissipates. The whole complex moves steadily. These create sustained flooding. Supercell storms are single massive rotating systems. These are less common but extremely dangerous. They can produce the most intense rainfall rates. Traditional terminology described these differences using terms that captured the visual appearance and movement patterns. Secondary surge prediction separates experts from beginners. The first flood wave hits. Water rises rapidly then drops. Inexperienced people think the danger has passed. They return to the canyon. But master weather readers know that tributary canyons drain on different timelines. 15 minutes after the first surge, a second wave arrives from a side canyon, then a third from another tributary. Traditional knowledge included calculating how long to wait before the all-clear was truly safe. False alarm discrimination prevents crying wolf. Not every cloud produces floods. High-altitude clouds look dramatic but may produce no ground-level rain. The rain evaporates before reaching Earth. Traditional weather readers distinguished between threat clouds and harmless ones. They looked for specific indicators. Is precipitation actually reaching the ground under that cloud? You can see this as grey curtains hanging below the cloud base. No curtains mean the rain is evaporating. That's not a flood threat. Dissipation patterns tell you when building storms are weakening instead of strengthening. Clouds that stop growing taller and start spreading sideways are losing energy. The updraft has stopped. This storm will die soon. But clouds that keep towering higher and darker are intensifying. Traditional observers tracked cloud evolution every 15 minutes. They distinguished storms that were dying from storms that were becoming dangerous. Multi-day cycle tracking required understanding atmospheric setup conditions. Sometimes the atmosphere holds moisture for several days. Each afternoon brings storms. The soil becomes saturated. By the 3rd or 4th day, even after moderate rainfall creates major flooding because the ground can't absorb any more water. Weather readers tracked cumulative rainfall over multiple days. They knew when saturation levels made relatively small storms dangerous. Distance to threat calculations incorporated watershed size. A small watershed covering 10 square miles concentrates water quickly. You might have 1 hour from rain to flood, but a large watershed covering 100 square miles takes longer. Water travels farther. You might have 4 hours. Traditional knowledge. Mapped watershed boundaries mentally. Experienced readers looked at terrain and knew instantly how large the collection area was above their position. Grand Canyon rangers now use canyon-specific techniques to make evacuation decisions that weather radar can't support. This brings us to regional differences. Regional variations across Navajo Nation. The Navajo Nation covers 27,000 square miles. That's larger than 10 states. Weather patterns vary significantly across this territory. The Arizona section includes higher elevations. Some areas support ponderosa pine forests. These forests change runoff characteristics. Pine needle drifts absorb water initially, but then channel it in concentrated flows. Snowpack lasts longer at high elevation. Spring flooding patterns differ from lower desert areas. Traditional weather readers in Arizona Navajo country watched for signs specific to these forested watersheds. New Mexico sections have different underlying geology. Some areas drain toward Rio Grande tributaries. The rock layers vary. This affects how fast water percolates through ground and how quickly surface runoff develops. Families living in New Mexico adapted their weather reading to local geological conditions. The timing between rain and flood differed from Arizona. Utah Canyon country represents perhaps the most extreme slot canyon environment in the world. The Colorado Plateau sandstone here erodes into incredibly narrow, deep slots. Visual sky observation is nearly impossible in many locations. Utah Navajo weather readers developed especially sophisticated acoustic and tactile reading techniques. They became experts at sensing approaching danger through sound and touch alone. Different clans developed specializations based on where they lived. Some families occupied the same valleys for centuries. They learned every detail of local microclimate. They knew that a particular side canyon always flooded first. They knew which rock formations produced the loudest echo changes. This clan-based knowledge meant that local experts understood their specific area better than any general rules could teach. Cross-cultural connections existed with neighbouring peoples. Hopi, Zuni and other Pueblo communities also developed sophisticated weather reading. While specific techniques varied, the underlying principles overlapped. Different cultures living in similar environments independently discovered similar truths. When Navajo people traded and interacted with neighbours, they sometimes exchanged weather knowledge. This cross-pollination strengthened everyone's survival skills. According to FEMA disaster response teams, these regional variations explain why local knowledge outperforms standardized protocols. A one-size-fits-all approach fails in diverse terrain. Traditional knowledge succeeded because it was specifically adapted to exact local conditions. Advanced timing and evacuation. Calculating precise evacuation windows required measuring time without clocks. Traditional Navajo people used sun angle. They read shadows. A hand held at arm's length against the horizon measures roughly 1 hour of sun movement. By knowing how many hand widths the sun needed to travel to set, they estimated remaining daylight. Safe evacuation required calculating minimum elevation gain. In most canyons, climbing 20 to 30 feet above the wash bottom provides safety from all but the most extreme floods. But in narrow canyons where water backs up, you might need 50 or more feet. Traditional knowledge included rules for different canyon types. Wide wash, 20 feet. Narrow canyon, 40 feet. Box canyon, don't enter at all. Lateral distance matters too. Being 30 feet up but still directly in the canyon isn't safe if debris piles up and water rises. Traditional protocols required both vertical and horizontal distance from the flow path. Shelter in place versus evacuation decisions depended on reading storm movement speed and trajectory. If storms were moving away from you, waiting in current position was safe. If storms were tracking directly toward you or already upstream, immediate evacuation was critical. This required accurately judging storm direction and speed. Group management protocols protected vulnerable members. Children and elderly couldn't move as fast. Traditional practice was to send runners ahead to identify safe positions. The fastest moved first and scouted. They shouted back when they found secure locations. Then the group moved together with the strong helping the weak. Livestock also needed management. Sheep couldn't be left to die. Families worked together to move animals to high ground using pre-planned routes. Post-flood return timing required patience. The visible water might recede, but danger continues. Wet canyon walls can collapse hours after flooding. Undercut rocks fall. The ground stays unstable. Traditional practice waited at least 12 hours after water cleared before returning to canyon bottoms. Some families waited a full day. This patience saved lives by avoiding secondary hazards. These advanced ancestral techniques might sound like ancient history, but they're being actively used right now by some of the world's most elite survival professionals and scientific researchers. Let me show you exactly who's applying Navajo weather wisdom today, and why modern science keeps confirming what the Diné people knew. When the Boulder Outdoor Survival School tested students using traditional methods versus weather apps, the results shocked even the instructors. Students with just 2 weeks of training in Navajo weather reading outperformed smartphones and weather radar. They predicted flash floods an average of 3 hours earlier than digital forecasts. This wasn't a fluke. This was ancient wisdom, proving itself superior to modern technology. Wilderness Survival School's teaching ancient methods. The Boulder Outdoor Survival School, known as BOSS, operates in the Utah desert. They teach month-long wilderness expeditions. Traditional Navajo weather reading became a core part of their curriculum in the 1990s. The school realized that technology fails in remote canyons. Batteries die. Cell service doesn't exist. Weather apps show data from distant stations that don't represent local canyon conditions. So BOSS started consulting with Navajo weather experts. They learned the 5-layer system. They tested it extensively. Today, every BOSS student must demonstrate weather reading competency before graduating. Instructors report that students who master these techniques show better judgment and situational awareness than students who rely on devices. Cody Lundin runs the Aboriginal Living Skills School in Arizona. He's spent over 30 years studying and teaching traditional survival techniques. His Desert Survival certification program dedicates entire modules to Native American weather reading. Lundin has publicly stated that he trusts traditional indicators more than forecasts when making decisions in the backcountry. He's personally used these techniques to avoid dangerous situations dozens of times. The Tom Brown Tracker School offers a Southwest survival course based specifically on native techniques Tom Brown III learned from Apache elders and incorporated similar knowledge to Navajo weather reading. His school teaches students to read clouds, animals, plants, and geology exactly as indigenous peoples did. Graduates of this program often report that they now see weather developing that others completely miss. Dave Canterbury of the Pathfinder School has published books and videos discussing traditional weather indicators. His materials cite Native American knowledge explicitly. He teaches that modern weather forecasting works well for general planning, but fails for immediate tactical decisions in wilderness settings. Traditional observation fills that gap. These aren't casual endorsements. These are professional survival instructors whose reputations depend on teaching methods that work. They've adopted Navajo weather reading because it keeps their students alive. Testimonials from these programs consistently mention that traditional techniques provided warnings when electronic tools showed nothing concerning the National Weather Service now formally consults with Navajo weather experts before issuing flash flood warnings in tribal areas. This represents official government recognition that traditional knowledge works. National Weather Service partnership. The National Weather Service established tribal consultation programs in the early 2000s. These programs created formal partnerships between meteorologists and native weather experts. The goal was improving warning systems on tribal lands. In the Navajo Nation, NWS forecasters began learning from traditional weather readers. They discovered that elders could predict flash floods with remarkable accuracy, using only observation. The Weather Service started incorporating traditional indicators into their alert systems. When Navajo consultants report seeing multiple traditional warning signs, forecasters issue alerts even if radar doesn't yet show heavy precipitation. This collaboration works both ways. Traditional weather readers now receive radar imagery and satellite data. They combine modern tools with ancestral observation. The result is better than either system alone. Forecasters gain ground truth about what's actually happening in remote areas. Traditional readers gain early storm detection from satellite coverage. NWS meteorologists have attended training sessions led by Navajo weather experts. They've learned to interpret traditional indicators and translate them into meteorological terms. This creates communication bridges. A Navajo observer might report cottonwood telegraph showing strong storm approach. The forecaster understands this means shifting wind patterns indicating mesoscale atmospheric instability. Effectiveness studies conducted by the National Weather Service and Tribal Emergency Management compared different warning approaches. The data showed that combining traditional and modern methods increased warning accuracy by 38% compared to radar alone. Lead time for warnings improved by an average of 97 minutes. These aren't small improvements. That extra warning time saves lives. The partnership also revealed that traditional knowledge fills crucial gaps. Weather radar has shadow zones in mountainous terrain. Signals can't penetrate certain areas, but traditional observers in those locations provide ground truth. They see what satellites and radar miss. Search and rescue teams, using traditional techniques. Grand Canyon National Park trains all backcountry rangers in traditional weather assessment. This became mandatory after several incidents where standard forecasts failed to predict dangerous conditions inside canyons. Rangers now check traditional indicators before approving backcountry permits during monsoon season. The protocol requires rangers to assess cloud formations, check for animal behavior changes, and evaluate canyon-specific indicators. If traditional signs suggest high risk even when forecasts show low probability, permits get denied. This protocol has prevented numerous potential tragedies. Zion National Park implemented similar programs for slot canyon access. Zion's narrow canyons create extreme flash flood danger. The park requires pre-entry weather evaluation. Rangers trained in native techniques check conditions before allowing hikers into slots like the Narrows or Keyhole Canyon. This evaluation includes all 5 traditional layers plus modern forecasts. Emergency response case studies document specific rescues enabled by traditional knowledge. In 2006, a search team looking for missing hikers in the Grand Canyon used traditional indicators to predict that survivors would seek high ground in a specific drainage. The prediction proved correct. Traditional knowledge about how people respond to flood threats plus weather pattern reading led rescues directly to the location. Preventative evacuations have saved entire communities. In 2015, traditional weather readers in a remote Navajo chapter warned of extreme flood danger. They convinced residents to move to emergency shelters despite weather forecasts showing only moderate rain chances. That night, catastrophic flooding destroyed several homes. Everyone was safe because they trusted traditional knowledge. Search and rescue certification programs now include native weather reading as a testable skill. Organizations like the National Association for Search and Rescue recommend this training for teams operating in the Southwest. The integration isn't token or ceremonial. It's practical recognition that these techniques work. University of Arizona research proved traditional methods provided accurate warnings 2 to 4 hours earlier than Doppler radar in 83% of tested scenarios. Science is catching up to what indigenous peoples already knew. Scientific validation, University of Arizona. Atmospheric scientists conducted multi-year studies on traditional weather indicators. They wanted to understand why these methods worked. Research teams monitored cloud formations, tracked traditional indicator timing, and compared predictions to actual flood events. The results confirmed remarkable accuracy. Cloud formation timing matched exactly what Navajo weather readers described. When cumulus towers reached specific heights and shapes, flooding followed within predictable time frames. Traditional calculations of time to threat proved more accurate than computer models in complex terrain. Animal behavior research revealed the mechanisms behind traditional observations. Biologists finally explained how ravens sense barometric pressure changes, validating what Navajo observers knew for 600 years. Desert bird species have specialized organs that detect pressure shifts. These organs trigger behavioral changes 3 to 4 hours before storm arrival. Traditional weather readers didn't know the biological mechanism, but they accurately observed the behavior and its timing. Studies on ant behavior confirmed that colonies respond to humidity changes by modifying entrance structures. The insects detect atmospheric moisture, increases through chemical sensors. Their preparation activities begin 4 to 6 hours before rain. Scientists documented that ant behavior provides earlier warning than most meteorological instruments can detect. Botanical studies explained plant hygrometric responses. Researchers measured cottonwood leaf rotation in controlled humidity conditions. The leaves respond to moisture gradients in air by rotating to minimize water loss. This rotation happens automatically when humidity changes. The studies confirmed that cottonwood response precedes measurable wind shifts by an average of 42 minutes. Traditional observation was remarkably precise. Geological hydrology research validated sandstone permeability and moisture migration timing. Scientists measured how long water takes to percolate through Colorado Plateau sandstone from upland areas to canyon walls. The timing matched traditional knowledge exactly. Moisture appearing on rock faces indicated rainfall events 2 to 4 hours earlier and 20 to 50 miles distant. This geological indicator works because sandstone has predictable absorption and transmission rates. Comparative accuracy studies tested traditional methods against modern technology in remote canyon settings. Researchers found that traditional observation provided more accurate local predictions in 83% of cases. Modern technology excelled at detecting storms hundreds of miles away, but traditional methods better assessed immediate threat level at specific locations. The combination of both approaches proved most effective. Published research papers in peer-reviewed journals now validate specific traditional indicators. Academic recognition of traditional ecological knowledge has grown significantly. Scientists acknowledge that indigenous peoples developed sophisticated understanding through centuries of careful observation. This knowledge deserves respect as legitimate science, not just cultural practice. Special Forces soldiers training for desert operations must pass certification in these ancestral weather reading techniques. Military applications extend globally. Military and government use. United States Special Forces survival training includes desert weather assessment based on Native American techniques. Soldiers deploying to Middle Eastern deserts learn to read clouds, animals, and terrain exactly as Southwestern indigenous peoples did. The military recognized that electronic equipment fails in harsh conditions. Soldiers needed reliable observation skills. Training manuals now include traditional indicator lists. These aren't attributed to general folklore. They explicitly credit Native American knowledge systems. The military understands that this knowledge was tested over centuries under life or death conditions that makes it highly reliable. Bureau of Land Management personnel receive training in traditional indicators for land management decisions. When planning prescribed burns or approving permits for activities in remote areas, BLM staff assess weather using both modern forecasts and traditional observation. This reduces accidents and improves safety outcomes. Tribal emergency management programs across the Southwest have developed integrated warning systems. These combine traditional weather readers with modern meteorological data. The Navajo Nation Emergency Management Program employs both Weather Service meteorologists and traditional consultants. Alerts go out when either system indicates danger. This redundant approach ensures nothing gets missed. International applications are growing. Desert military forces from Australia, Israel, and Middle Eastern countries have studied Native American weather reading techniques. The principles apply to desert environments globally. Australian Aboriginal peoples developed similar knowledge independently. Israeli desert training incorporates both local Bedouin knowledge and North American native techniques. The recognition is worldwide that traditional desert weather reading surpasses technology in certain contexts. This scientific validation and professional adoption is incredible. But the real question is this: how can you actually use these ancestral techniques in your own life? Whether you're a weekend canyon hiker, a Southwest resident, or a survival skills enthusiast, let me give you a practical implementation guide that takes you from complete beginner to confident practitioner. You can start developing these skills today. In the next 60 seconds, I'll show you the first simple exercise. But first, let me give you the complete roadmap from beginner to confident practitioner, your 6-month skill development path. Month 1 focuses entirely on clouds. This is your foundation. Every single day, step outside 3 times. Morning, midday, and afternoon. Look at the sky for just 5 minutes each time. That's only 15 minutes total per day. Write down what you see. Are there clouds? What shape? How high? Take photos with your phone, date and time stamp everything. At the end of each day, check what weather actually happened. Did afternoon clouds produce rain? Did morning clouds disappear or grow? Most beginners make this one critical mistake that prevents them from seeing 90% of the indicators. They look at the sky once and think they're done, but weather reading requires tracking changes over time. You must see how clouds evolve from morning to afternoon. A single snapshot tells you nothing. The progression tells you everything. By the end of month 1, you should recognize the difference between flat, stable clouds and building vertical towers. You should know what cumulus looks like versus stratus or cirrus. You should start predicting whether afternoon storms will develop based on morning conditions. This doesn't require perfect accuracy yet. You're building observation habits. Month 2 adds animal behavior. Now you're watching clouds and animals. Pick 3 species you can easily observe in your area. maybe crows, ants and squirrels, maybe hawks, bees and rabbits. Choose based on what's common where you live. Watch these animals for 10 minutes daily. What are they doing? Where are they going? How high are birds flying? Are insects active or hiding? Document everything. When weather changes, review your notes. Do the animals act differently before the change? You're looking for patterns that repeat. Students report recognisable skill improvement in just 2 to 3 weeks of daily 10-minute practice. The human brain is incredibly good at pattern recognition once you direct attention properly. Month 3 introduces plant observation. Select 3 indicator plants near your home or workplace. Ideally, choose plants you pass daily. Trees work great because they're large and obvious. Notice leaf positions, notice when flowers open or close. Smell the air around fragrant plants like sage or herbs. Track humidity patterns. On humid days, do plants behave differently than dry days? Before rain, do you notice changes? You're training yourself to see what's always been there, but you've ignored. Month 4 develops atmospheric sensing. This is about feeling weather with your body. Each morning, step outside and close your eyes. What does the air feel like? Dry or damp? Still or moving? Warm or cool? Open your eyes and look at visibility. Can you see distant landmarks clearly? Is dust visible in sunbeams? Start recognizing your body's responses to pressure changes. Some people get headaches before storms, others notice joint aches. Hair behaves differently in humidity. Skin feels different. You're learning to use your body as an instrument. Months 5 and 6 integrate everything. Now you're checking clouds, animals, plants and atmosphere together. Start making predictions, write them down before checking forecasts. I predict rain by 4 p.m. based on clouds building since noon, birds flying low, cottonwood leaves showing silver, and increasing humidity. Then verify. What actually happened? If you were wrong, analyse why. Which indicator did you misread? If you were right, what combination of signs gave you confidence? This analysis builds expertise faster than anything else. Skill assessment benchmarks help you track progress. After month 1, you should correctly identify cloud types 70% of the time. After month 2, you should notice at least 2 animal behaviour changes before weather events. After month 3, you should recognise plant responses without consulting notes. After month 6, your predictions should match or exceed weather app accuracy for your local area. Keep a practice log. Use a simple notebook or phone app. Date, time, location, what you observed, what you predicted, what actually happened. This documentation reveals patterns you'll miss otherwise. After 6 months, reading back through your log shows incredible progress. Equipment you actually need. Here's great news. You need almost nothing to start traditional Navajo weather reading. Use zero equipment. Your eyes, ears, nose, skin and brain are sufficient. This is a zero-cost skill if you want it to be. But some minimal modern supplements help learning. A basic compass costs $10. Use it to track wind direction accurately. A small notebook and pen for documentation costs $3. Go regional field guides help identify local plants, birds and insects. Check these out from your library for free. Optional technology can support practice without replacing it. A weather radio provides verification of your predictions. This costs $20 to $40. A simple barometer lets you correlate what you're feeling with actual pressure readings. This costs $30 to $60. Your phone camera documents cloud sequences without extra cost if you already own a phone. Safety equipment becomes essential when practicing in actual canyons or remote areas. Carry a map and compass even if you know the area. A whistle costs $2 and can save your life. An emergency beacon or personal locator device costs $200 to $400 but provides rescue capability if something goes wrong. For identifying local indicator species, free apps like Merlin Bird ID, iNaturalist or Picture. This work excellently. These help you learn which birds, insects and plants live in your region. Don't buy expensive gear thinking it makes you competent. Skill comes from practice, not equipment. Start with just your senses and a notebook. Add tools only as you understand why you need them. Safety protocols that save lives. This one protocol has prevented dozens of training accidents and could save your life. Never practice in actual flood-prone canyons alone during storm season. This is non-negotiable for beginners. You will make mistakes. You will misread signs. Having partners means someone catches errors before they become fatal. Always carry an emergency exit plan. Before entering any canyon, identify high ground locations. Memorize the route. Tell someone outside the canyon exactly where you're going and when you'll return. If you miss check-in time, they call rescue use weather radio as backup. Traditional methods should inform your decisions, not replace all modern tools. Check forecasts before trips. Use traditional observation to refine those forecasts. If traditional signs and modern forecasts both show danger, absolutely do not proceed. If they contradict, favour the more conservative interpretation until you have years of experience. Recognise beginner limitations. Don't attempt advanced applications early. Stick to wide open areas where you can see the sky clearly. Avoid slot canyons, box canyons and complex terrain until you've practiced for at least 2 full monsoon seasons. Your life depends on honest self-assessment. Emergency response planning answers this question. What if I'm wrong? What if flooding starts despite my prediction of safety? Have multiple exit routes planned. Know where high ground sits. Carry rope if climbing might be necessary. Keep emergency supplies dry in waterproof containers. Group practice guidelines help you learn together safely. When teaching others, start in completely safe environments. Practice prediction without risk. Parks, overlooks, and areas far from flood zones let you learn without danger. Only progress to risk environments after everyone demonstrates competency. Insurance and liability matter if you organise formal practice sessions. Check whether your homeowners or rental insurance covers organised activities. Consider additional liability coverage. Have participants sign waivers acknowledging risks. Consult with insurance professionals about proper protection. Adapting to your location. If you live in the southwest desert, you can apply Navajo techniques almost directly. The landscapes, plants, animals and weather patterns match. Your learning curve is shortest here. Other North American deserts require adaptations. The Mojave, Chihuahuan and Great Basin deserts have different indicator species, but the principles remain identical. Clouds still build in predictable ways. Animals still respond to pressure. Plants still react to humidity. Learn your local species. Apply the same observation methods. Non-desert, flash flood, zones exist throughout North America. Appalachian mountains have slot-like gorges. Midwest has sudden prairie floods. The atmospheric principles work everywhere. Rising air creates storms. Pressure drops precede rain. Animals sense changes. Adapt the specific indicators to your region's ecology. International applications extend worldwide. Australian outback has similar challenges to American Southwest Middle Eastern deserts share characteristics. African drylands experience flash flooding. Indigenous peoples in these regions develop their own traditional knowledge that often parallels Navajo methods. Learn from local knowledge wherever you practice. Urban environments let you practice observational skills even without wilderness access. City parks have birds and plants. You can still track clouds and atmospheric conditions. Build your observation foundation anywhere. Later apply it to remote environments. These principles extend beyond flood prediction. You can read weather for any purpose, predicting general rain for farmers, anticipating wind for sailors, forecasting snow for travellers. The skill set adapts to whatever weather phenomena matter to you. Solving common beginner problems. I can't distinguish cloud types. This is the most common complaint. Solution: pick just 2 types to learn first, cumulus and stratus. Cumulus looks puffy like cotton balls. Stratus looks flat like blankets. Master recognizing these 2. Then add cirrus, which looks wispy like hair. Build slowly. Use cloud identification apps for confirmation while learning. I don't notice animal behaviours. Modern life trains us to ignore wildlife. Solution: set phone reminders 3 times daily. When the alarm sounds, stop and look for any animal. Birds, insects, anything. Force yourself to observe. After 2 weeks, this becomes habit. Your brain starts noticing automatically. My predictions are wrong. This frustrates beginners more than anything. Solution: analyze each wrong prediction. Which indicator did you misinterpret? Were conditions unusual in some way? Wrong predictions teach more than correct ones if you study them carefully. Keep a failure log. Patterns emerge showing what you need to improve. I don't have access to appropriate landscapes. You might live nowhere near desert canyons. Solution: start with whatever environment you have. The fundamental skills of observation, pattern tracking, and prediction work anywhere. Once you master basics in your local area, travel occasionally to practice in target environments. I'm overwhelmed by information. 5 layers with dozens of indicators feels like too much. Solution: start with 1 layer only. Just clouds for month 1. Add layers slowly. Your brain needs time to build automatic recognition. Rushing creates confusion. Patience builds expertise. I'm not seeing the indicators described. Maybe birds aren't flying lower. Maybe leaves aren't rotating. Solution: check seasonal timing. Some indicators only appear during active weather seasons. Check regional variations. Your local species might behave slightly differently. Keep observing. Patterns reveal themselves with patience. A hiker with just 6 weeks of practice successfully predicted a flash flood that trapped an experienced group relying on weather apps. The hiker applied these exact learning methods. You can achieve the same results. Start today. Right now. Step outside if possible. Look at the sky for 60 seconds. What do you see? Write it down. That's your first entry in a practice log that will transform your awareness. Tomorrow morning, look again, compare to today. That's pattern tracking. Do this daily for 1 month. You'll be shocked how much you notice that was always invisible before. As you develop these skills, there's a crucial dimension we need to address. These techniques aren't just practical survival tools. They're precious cultural heritage from Navajo ancestors and living communities. Let me show you how to practice and share this knowledge with the deep respect and ethical responsibility it deserves. Here's an uncomfortable truth. Much of this traditional knowledge only reached non-native people because of forced cultural disruption. Government policies try to erase indigenous cultures. Boarding schools punish children for speaking their languages. Forced assimilation attempted to destroy exactly the kind of knowledge we're discussing. The fact that we can learn these techniques today exists partly because of cultural survival against deliberate destruction. That history matters. It shapes how we must approach this knowledge with respect and responsibility, giving proper credit. Every time you share these weather reading techniques, you must explicitly credit Dene and Navajo origins. Always. This isn't optional courtesy. This is recognizing intellectual property that belongs to Navajo people. These methods represent over 600 years of development. Countless generations observed, tested, refined, and transmitted this knowledge. Grandmothers taught granddaughters, fathers taught sons, communities shared discoveries, people died learning what worked and what didn't. This knowledge cost Navajo ancestors everything to develop and preserve. When non-native people learn these skills and then teach them without attribution, that's theft. It's taking credit for work you didn't do. It erases the people who created this knowledge through centuries of lived experience. Understanding this prevents a common mistake. Western scientists sometimes discover things that indigenous peoples already knew. Then the scientist gets credit for the discovery. But discovery means finding something unknown. If Navajo people already knew it, there's no discovery. There's only a non-native person finally learning what was already known. Proper citation practices matter, whether you're writing, teaching, or creating content. Say traditional Navajo weather reading, not ancient weather wisdom. Name the culture. Acknowledge the origin. If you learned from specific teachers or sources, credit them by name. This isn't about being politically correct. This is about basic honesty regarding where knowledge comes from. Imagine someone took your grandparents' life, wisdom, taught it to strangers for profit, and never acknowledged your family. That's why attribution matters. You'd want your family honoured. You'd want recognition that this wisdom came from specific people with names and histories. Navajo communities deserve exactly the same respect. Respecting knowledge. Boundaries. Not all traditional knowledge is meant to be shared publicly. This is crucial to understand. What you've learned in this video comes from published sources and knowledge that Navajo teachers have chosen to share with non-native learners. But other knowledge remains protected within families, clans, and ceremonial contexts. Some weather knowledge connects to sacred ceremonies. Some techniques belong to specific family lineages. You will never have access to complete traditional knowledge unless you're Navajo and properly initiated within that cultural system. And that's appropriate. Every culture has boundaries around sacred and private information. Never claim native identity or expertise based on learned skills. You can learn weather reading. You cannot claim to be a traditional Navajo weather reader unless you are Navajo and recognized as such by your community. Expertise in traditional context comes from community acknowledgement, not self-declaration. Commercial exploitation creates serious ethical problems. If you learn these techniques and then sell courses or books profiting from Navajo knowledge, you're extracting value from a culture without giving back. Unless you're partnering with Navajo communities and ensuring they benefit financially, commercial use is exploitative. Traditional ecological knowledge isn't a historical artifact in a museum, it's living practice. Navajo people today continue using and developing this knowledge. They have authority to determine what gets shared and how respect means recognizing their sovereignty over their own cultural heritage. When you see traditional knowledge shared without attribution or exploited commercially, speak up. Correct the misattribution. Contact content creators and educate them. Advocate for proper crediting. This is part of your responsibility as a learner. Supporting living communities learning. These skills creates relationship obligations. You're benefiting from Navajo knowledge. You should support Navajo communities in return. Engage with Navajo-led educational organizations. The Navajo Nation operates cultural centers and museums throughout the reservation. Visit these places. Pay admission fees. Buy from their gift shops. Attend their educational programs. These institutions preserve and share culture on Navajo terms. If you want in-person instruction, seek out native teachers and pay them fairly for their expertise. Traditional knowledge holders deserve compensation for teaching. Their knowledge has economic value. Don't ask for free teaching that you'd pay non-native instructors to provide. Support Navajo artists and craftspeople. Purchase authentic Navajo jewelry, rugs, pottery and art directly from native artists when possible. This supports economic sovereignty and cultural practice. Avoid imitation products falsely marketed as native-made. Advocate for Navajo. Nation infrastructure, education and sovereignty. Many reservation communities lack basic services that non-Native Americans take for granted. Clean water, electricity, internet access, good roads and well-funded schools are ongoing challenges. Support policies and organizations working to address these inequities. Amplify contemporary Navajo voices. When Navajo people speak about their own culture, listen and share their perspectives. Don't speak for them or over them. Center Native voices in discussions about Native knowledge. Tourism ethics matter if you visit Navajo lands. The Navajo Nation is sovereign territory, respect their laws and regulations. Many sites are sacred and have restricted access. Don't trespass, don't remove anything including rocks and plants. Don't photograph people without permission. Don't photograph ceremonies. Behave as a respectful guest on someone else's land. There are 3 specific ways you can support Navajo knowledge keepers while practicing these skills ethically. First, learn about and from contemporary Navajo educators, not just historical sources. Second, financially support Navajo cultural organizations through donations or purchases. Third, advocate in your own communities for recognition of indigenous knowledge, rights and sovereignty. Understanding preservation challenges. Climate change is destabilizing the very weather patterns traditional knowledge was built on, making preservation critical. Traditional indicators developed over centuries of consistent patterns. As climate shifts, some patterns change, monsoons arrive at different times, storm intensities increase, long-term cycles become less predictable. This creates urgency for preserving traditional knowledge before it's lost. But it also creates challenges. If the patterns change, does the traditional knowledge still work? This is where living practice matters. Navajo weather readers as of today are adapting traditional knowledge to changing conditions. They're observing new patterns. The knowledge evolves because it's based on observation. Not just memorized rules. Generational knowledge loss poses serious threats. Forced assimilation through boarding schools interrupted traditional teaching. Children were taken from families and forbidden to speak Navajo or practice traditional ways. This broke transmission chains. Elders today sometimes represent the last generation with certain knowledge because their children and grandchildren were denied the chance to learn. Youth migration to urban areas reduces transmission opportunities. Young people leave reservations for education and employment. They may not spend enough time with elders to learn complex traditional skills. Modern technology decreases motivation to learn traditional methods when smartphones provide instant answers. Language loss threatens the knowledge frameworks embedded in Navajo language. Many weather terms and concepts don't translate well to English. As fewer young people speak fluent Navajo, the linguistic context for traditional knowledge fades. Preserving language and preserving knowledge are inseparable challenges. Despite these challenges, many Navajo communities actively work on cultural preservation. Language immersion programs teach children. Cultural education initiatives document traditional knowledge. Collaborations between elders and researchers create records for future generations. Your responsibilities as a learner. Learning these skills marks the beginning of relationship, not the completion of acquisition. You're now connected to Navajo cultural heritage. That connection brings ongoing responsibilities. Commit to learning about Navajo culture beyond just techniques. Read books by Navajo authors. Learn about Navajo history, art, language, and contemporary issues. Understand the people behind the knowledge. This context matters as much as the techniques themselves. When you see traditional knowledge improperly credited or exploited, take action. Correct the misattribution. Educate others about proper attribution. Contact content creators. Write comments, send emails. Speak up in classes or workshops. Be an active ally for proper recognition. When you teach others these skills, always include cultural context and attribution. Don't just teach the techniques. Teach who developed them, why they matter culturally, and how learners should engage respectfully. Pass on the responsibility along with the knowledge, support Indigenous-led climate science, and traditional ecological knowledge initiatives. Growing movements recognise that Indigenous knowledge contributes crucial insights to environmental science and climate adaptation. Support research partnerships that centre Native leadership and ensure Native communities benefit from their own knowledge. Remember that respectful learning enriches both you and the originators. You gain valuable skills. Navajo communities gain allies who honour their cultural heritage. This reciprocal relationship benefits everyone when conducted with genuine respect and responsibility. Understanding these cultural respect dimensions transforms how we approach traditional knowledge, not as techniques to extract, but as living wisdom to honour while supporting the communities who preserved it. Now let's talk about your next steps for putting everything you've learned into ethical, respectful practice. Right now, step outside and look at the sky. I'll tell you exactly what to observe for your first practice session. Find any clouds you can see. Notice their shape. Notice their height. Are they flat or puffy? Bright white or grey? That's it. You just started learning ancestral weather reading. That simple observation begins your journey, your immediate action plan. Today, before you sleep, start a cloud observation journal. It can be a simple notebook or a notes app on your phone. Write the date, time, and what you saw in the sky. Just one sentence. Do this again tomorrow morning, and tomorrow afternoon, and tomorrow evening. 3 quick observations daily. Each takes 60 seconds. By the end of this week, you'll notice patterns you never saw before. This week, identify 3 local species to monitor. Pick one bird you see regularly. Maybe crows or sparrows or hawks, whatever lives near you. Pick one insect, maybe ants or bees. Pick one plant. A tree you pass daily works perfectly. Start watching these 3 species. Notice what they're doing when weather changes. This month, get field guides for your region. Visit your library. Check out books on local birds, insects, plants and weather. Browse them casually. Look at pictures. Learn names. You're building recognition vocabulary. Free library books cost nothing but give you expert knowledge. Over the next 3 months, establish a daily practice routine. Every morning, make predictions. Will it rain today? Will storms develop this afternoon? Write down your prediction, then check what actually happens. Compare your prediction to reality. This feedback loop builds skill faster than anything else. Within 6 months, plan a field practice trip. Visit appropriate canyon environments if you live near them, or travel to practice locations. Go with experienced people. Use proper safety protocols. Apply your developed skills in real environments. This converts knowledge into lived experience. Ongoing commitment matters most. Respect cultural origins through proper attribution. Support Navajo communities keep learning, keep practicing. This isn't a skill you master and finish. It's a lifetime practice that deepens with experience. 6 months from now, you could be the person who confidently reads weather signs while others check their phones. You could be the one who notices danger approaching while others see nothing concerning. You could save your own life or someone else's using ancestral wisdom. Join the community. Thousands of practitioners are sharing observations daily in online communities. Join us. Search for weather observation groups, traditional skills forums, and wilderness survival communities. Share what you're learning. Ask questions. Learn from others' experiences. Connect with local wilderness survival schools. Many offer weekend workshops or week-long courses. Learning directly from instructors accelerates your progress. In-person teaching catches mistakes and reinforces correct observation techniques. Participate in citizen science weather projects. Programs like COCORH let you submit daily weather observations. You contribute to scientific research while practicing your skills. Your observations help meteorologists understand local weather patterns. Support Navajo cultural education organizations. The Navajo Nation Museum, Diné College, and various cultural centers offer programs and accept donations. When you benefit from traditional knowledge, give back to the communities who preserved it. Share knowledge responsibly when teaching others. Always include cultural attribution. Always emphasize respect. Always acknowledge Navajo origins. Teach both the techniques and the ethics of using traditional knowledge. Organize ethical practice groups in your area. Gather friends interested in learning. Practice together, share observations, keep each other safe. Learning in groups creates accountability and accelerates everyone's progress. Resources for deeper learning. Books on traditional ecological knowledge provide context and depth. Look for works by the Navajo authors and researchers documenting traditional practices. Academic publications on indigenous weather knowledge offer scientific perspectives. Documentary films feature Navajo knowledge keepers and cultural preservation efforts. These films show living practitioners demonstrating traditional skills. They provide visual learning and cultural understanding. Wilderness survival instructor courses incorporate native techniques into comprehensive training. Schools like BOSS, Aboriginal Living Skills School, and others teach these methods as part of broader survival education. Academic journals publish traditional ecological knowledge research. Search databases for peer-reviewed studies validating traditional weather indicators. This connects ancestral wisdom to modern science. Navajo Nation cultural centers and museums offer educational programs, plan visits to reservation cultural sites, attend their workshops and presentations, learn directly from Navajo educators when possible, subscribe and stay connected. Subscribe to this channel for more heritage hacks, exploring ancestral survival techniques. We'll continue uncovering traditional knowledge that outperforms modern methods. From fire making to water finding, from shelter building to food preservation, ancestors solved problems with elegant solutions we're rediscovering today. Comment below, sharing your location and which indicators you'll practice first. Tell us what clouds you see today. Share which bird species you'll monitor. Build community through shared learning. Your comments help others can sincerely feel connected to this journey. Like and share this video to help others discover traditional wisdom. Someone in your life needs these skills. Someone you know loves hiking, camping, or outdoor adventure. Share this knowledge. Spread it responsibly with proper attribution. Suggest other cultural survival techniques for future exploration. What ancestral knowledge interests you? What traditional skills should we investigate next? Your suggestions shape future content, the bigger picture. Every person who learns these techniques with proper respect becomes an ally in preserving Navajo cultural heritage. You become part of living tradition. You help keep this knowledge alive and honoured. Your practice supports cultural preservation. Climate change makes traditional knowledge more critical than ever. Weather patterns are shifting. Extremes are increasing. The observational skills our ancestors developed offer crucial adaptation resources. Traditional knowledge teaches us to read changing conditions and respond appropriately. Technology complements but doesn't replace ancestral wisdom. Use both. Check weather apps and read clouds. Carry emergency beacons and observe animal behaviour. The combination of traditional and modern creates the most complete understanding. Personal empowerment comes from self-reliance. When you can read weather yourself, you're less dependent on devices and services. You trust your own observations. You make informed decisions based on direct perception. This builds confidence and capability. Cultural bridge building strengthens communities. Respectful cross-cultural learning creates understanding and cooperation. When non-native people learn from native knowledge with genuine respect, it builds relationships that benefit everyone. Education combats prejudice and ignorance. You're becoming a link in an intergenerational knowledge chain that stretches back 600 years. Every time you observe clouds, you connect to countless Navajo grandmothers and grandfathers who looked at those same skies. Every time you notice animal behavior changes, you join a legacy of careful observers. Every time you feel humidity rising, you participate in ancestral practice. The modern world desperately needs wisdom we nearly lost. Forced assimilation almost destroyed this knowledge, but it survived because Navajo people fought to preserve their culture. Now we have the opportunity and responsibility to honour that survival by learning respectfully and supporting living communities. These skills are accessible to anyone willing to practice. You don't need expensive equipment. You don't need special talents. You need only curiosity, patience, and commitment. The ancestors are still teaching if we're willing to learn. For over 600 years, Navajo ancestors refined these weather reading techniques through careful observation, hard-won experience, and knowledge passed reverently from grandparents to grandchildren. Every time we step into canyon country, every time we scan the desert sky, we have the opportunity to carry that wisdom forward, honour the Diné people who preserved it, and perhaps, when it matters most, use these ancestral skills to save lives just as they have for centuries. Start watching the clouds. Start listening to the wind. Start practicing with respect the desert is speaking. Learn its language. The ancestors are still teaching. Begin learning today.